So this morning's talk is meant to be a technical deep dive in how to properly secure and harden your accounts. We're going to be going deep into how some of these functions work. I'm going to be throwing a lot of code at you, a lot of different examples. But to level set, this is meant to be a more technical talk, so I'd rather you leave disappointed now than angry at the end if that's not your cup of tea. So what we're going to go on through this talk, hopefully why you're here is you want to know how to better secure your AWS environment, how you can make sure all the accounts that are in your environment follow the rules and that they're complying with the governance policies that you lay out for your organization. You want to be able to detect threats in one or many accounts inside of your environment. And you're trying to figure out what tools should I be using? What are the best practices from both an AWS perspective as well as what's out there in the community? And how can I make sure that as we go and start to create new accounts in our organization, how can I make sure that they're secure by default? So let's get started with chapter 1. I want to start with the basics. This is really kind of an overview for folks that are perhaps more seasoned on the AWS platform, but it's really important to understand how some of the security basics on AWS work because they're very key in how we deliver security as an offering on the platform. So the first part that is really critical to make sure that you understand is the shared responsibility model. So the way the shared responsibility model works on AWS is that AWS is responsible for the security of the cloud. So we make sure that the facilities that we operate in, that the resources that we're providing to you from a hypervisor on down level, that's an Amazon responsibility. But you as the customer also have a responsibility in this place. When you go to develop an application, be it on an EC2 instance or a Lambda function or an RDS database, you need to make sure that you're properly safeguarding and securing the default configuration of that resource so that you're not publicly exposing it. So the good analogy here is that if you were to stand up a website on AWS and you were to make a login portal, and in the login portal there was a credential which you used to log in, which is root, and the password is 1234, that's not an Amazon problem, right? That's an example of an application misconfiguration, and that would fall to your side of the shared responsibility. But this gets a little bit more abstracted when we start looking at some of the newer services that AWS offers, like containerized services. As we can see, basically the shift starts to occur where AWS starts to become more responsible for these services. So we start to deal with platform management and going up the stack a little bit. And then even further abstracted when we look at some of the newer services, which would be fully operating independent like Lambda, where basically AWS is responsible for almost everything. You as a customer, though, are still responsible for the, again, code sanitization of that Lambda function. So it's really important to, from the outset, set a standard that you're going to follow. There are a number of different control frameworks that you can leverage that will give you information about how to harden an environment based on not just opinion in your environment, but an actual recognized standard. So some examples, NIST, CIS, CGIS, HIPAA. These are all different frameworks that you can use to put as an outset. And to make that process easier, we have a quick start portal that will help you align to those control frameworks in a templatized way, but we also will provide you with a security controls matrix that outlines for each one of these quick starts where AWS is responsible for a control and where you as a customer are responsible for a control and where there's overlap between them. So an example of how we can start to use this as code, this is an open source package that's available on AWS Labs. And what it does is does a CIS benchmark check against a particular account. So you can see not a lot to actually make this work, but the outputs vary based on what your use case is. So we can report in an HTML document that you can provide to your leadership that gives you a handy red light, green light type dashboard. But you can also get raw JSON back that you can use in a Lambda function or in a downstream processor so that if you want to basically run that Python function in a scheduled iteration, you can take the outputs and loop over them to get your end result. Or if what you really care about is just show me the ones that failed, you can also get the output of just the control elements that had failure. So again, we can use that for a post-processing trigger. The idea is that we want to supplement security events so that we're leveraging automation as much as possible. You're going to see it as a repeated theme this morning. For better or worse, humans, we do a lot of things really well, but things that we don't do well are often around repeatability and under high stress. At least if you're leveraging a high degree of automation in your environment, you'll know that it's consistently be done a certain way. And even if that way is not always correct, you at least know the pattern that was followed during the entire iteration. You want to make sure that you're preventing bad implementations before that they're actually committed, and we're going to talk a little bit about how to do that. And we want to address violations of policy immediately rather than relying on a human to be in the loop. So we don't want to wait basically for a dashboard event to go off. We want that resolution to happen automatically. So as we said, the slides will be available afterwards, but I wanted to provide a couple examples of open source solutions that can help in this specific space, both from an AWS offered perspective as well as some community supported perspectives. So let's talk a little bit about automation. So one of the areas that's really important to focus on in terms of automation is dealing with patching. We want to make sure that our environment is properly patched and that we're making sure that we're not exposing ourselves to vulnerability by having legacy applications running unpatched for an extended period of time. So how do we do that? One service that we can use to do this is Systems Manager. And one of the cool functions within System Manager is that we can deploy patches to an identified subset of EC2 resources. So as an example, what we can do is identify a particular subset of hosts, and we can associate it with a patch baseline. And that patch baseline can align with whatever your organization's security posture is. So it could be everything has to be patched up into the moment. It could be that there is a specific package that we're looking for a specific version to be present. We can associate it with that. And then when we run that report, we'll get back basically a list of hosts that are compliant with that finding or non-compliant. And because that attribute is queryable, we can use non-compliance to trigger other downstream events like automatic patching of an identified host. So one of the other really powerful functions, though, that goes overlooked when we talk about services like System Manager is the run command. So the reason that the run command should be really interesting to you as security practitioners is that it does something really powerful. So I'm going to take everyone back a little bit. It's the early 90s, and there's this movie about dinosaurs running around, and people are really excited. So there's this entity that works in this park, some sort of a Jurassic Park, I'm told. And he's sitting down at his terminal, and he types this command into his terminal. And the command he types is white rabbit. And then suddenly there's velociraptors running around a park, and we don't know exactly what he did to let these raptors out, right? So what we've just demonstrated in sort of a 1990s awesomeness style was an insider threat. So we've got an adversary that is disgruntled, that feels like he or she wasn't being given the credit that they deserve, and so they're going to do damage to the company. So in this case, the difficulty is that the adversary used that command, so we don't know what they actually executed. This is why the run command is powerful. The run command allows you to execute code on an EC2 instance without requiring a bastion host to execute that code. So I no longer need to give my developers direct shell access to our environment. Instead, I can use the run command to allow them to execute code functions via the run command. The reason that that's really powerful is because it's an API. That means it's going to flow through Cloud Trail. And that means that I can get every keystroke that an operator sends and record it, and I can use that for threat intelligence to understand what that person did. So that Cloud Trail data can also be migrated to a separate account so that I've got a separate log store in the event that our adversary is clever and figures out a way to basically disable or delete Cloud Trail logs as well. So now I've got a second data store for that log data. But let's go deeper. There's another service that we run which is called Guard Duty. So using that same model with Guard Duty, what Guard Duty will allow you to do is basically get threat intelligence about your environment. It will allow you to understand what resources are communicating with, and if they're communicating with hosts that are known to be bad actors, or if they're performing operations that are of significant security concern to you. So a data flow example is that I've got an actor that's using a run command, and they're trying to be clever by installing a Trojan on that host, so they're on the EC2 resource. So they're still ultimately going to get their code on because we're not actively looking at the keystroke at this point. So how do we deal then with the payload that this particular actor is installing on this, even using the run command? The way that we can address that is with a guard duty automated kill chain. So in this case, what guard duty would do is look at the traffic that's flowing through the VPC, and then we can create a custom CloudWatch event. And that CloudWatch event can look for things like guard duty sending an alert for a particular type of threat that we're going to identify, and then we can use Lambda as a responder. So an example of the rule set that we would create is we're basically looking for a guard duty finding to pop up. And when we see a guard duty finding, we're going to pass that to this Lambda function. And basically the subtext here is that it's 9 lines of code, and basically it's in that do response part that we can decide based on our company's culture or our posture what we want to do. So it could be that we want to go and identify the credential of the user that made the call and then revoke access to them. Or in some organizations, it's that they want to allow the attacker to persist a little longer so that they can understand their capabilities and what they're actually going after. So it very much depends on what your risk posture is. So in this example, basically going back, again, the adversary has made the call to a known malware endpoint. Guard duty has identified that it's talking to a known command and control host. But in this case, the Lambda function has detected that guard duty finding, and we can use that to basically auto shut down the EC2 instance or bring the EC2 instance offline. So going a little deeper, though, let's talk about networking. So from a networking perspective, we need to make sure that we can see what's going on inside of our VPC and that we can, again, automate when we detect anomalous behavior in the VPC. So how do we do that? One of the technologies that we offer inside VPC is called VPC flow logs. And what flow logs will give you is basically the equivalent of NetFlow. I can see different source and destination of ports and protocols, where a host is communicating, and whether or not that traffic would be allowed or rejected based on things like a security group. So did the traffic go through and actually go to the resource, or are we blocking that resource? And incidentally, this is a really good way to also validate to an auditor that if you say that a security group is preventing traffic from interfacing with a resource like an EC2 instance, how can I demonstrate that and prove that a security group is actually doing what we say it's doing? The answer is it would show up in the flow logs, and you'll be able to demonstrate that this packet was blocked by this particular policy. So let's play that out. So let's say we've got an application in our environment, and the application is making unusual calls, so we're starting to see anomalous behavior, so we want to look a little deeper. So in this case, what we would do is we would use the flow log group with a CloudWatch event, and much like the previous example, we'll create a custom metric. And in this case, the custom metric that we're looking for is filtering on SSH reject traffic. So in this case, if we see greater than 10 rejects within the flow log, we'll use that as basically an indicator that a host is compromised and that we think that someone's actually performing a brute force inside of the environment. And then we can use that in correlation with an SNS topic and a Lambda responder to basically go and identify the resource that is being used to call that reject traffic and do something like disconnect its elastic network interface and bring it offline. But in parallel, remember that Lambda doesn't have to do just one thing. We can make it do multiple things in the same execution. So if you're using a ticketing service that supports an API, you can, in parallel, have the Lambda function open up a ticket on your behalf that indicates what the actor was doing, what the resource was, what the event was that you chose to do, which could be to bring the host offline, and also whether or not that event was successful or not, all inside of the ticket, so that way when your responder goes to look at the environment, they already have everything captured in the ticket for you. But let's go even further. How can we better automate that to make it more practical for a larger enterprise? So we know that there are security threats that you all likely see in your environments, and some of our larger customers and government customers have threat intel feeds that they subscribe to and that they publish. So we're going to use that model in this example. What we're going to do is basically identify a list of actors that we're going to classify as hostile to our community. And what we're going to do is we're going to put that inside of a JSON file. And in this case, I'm labeling it IP threats. So this would contain CIDR ranges of folks that we know are being malicious, both from our AWS logs, as well as perhaps aggregate logs that you have from information sharing agreements or through your own telemetry that perhaps you're collecting on your edge. We can use a service, though, like SNS to basically broadcast when this file will change inside of your environment, and then use Lambda responders and all of the accounts that you organize to input that threat feed and then associate it with something like a security group. So in plain English, you can put a threats file basically inside of your organization, make changes to it on the fly, and then have it be associated with an SNS topic that various accounts are listening for. And when you make changes to the file, your SNS topic or your Lambda function will basically fire and change the security group. So to visualize that a little bit better for you, let's say that we've got our threat feed and we've got a security account inside of an organization, and we've made a change to that file. We can use an S3 event trigger to basically broadcast an SNS topic notification that the file has changed. Because all the downstream accounts are listening to that SNS topic, they will go and pull that threat feed into their account. They'll spin up that Lambda function to loop over the new IP ranges to look for what changed in the new file. And then they can go and report back to that S3 bucket that, yes, I've acknowledged this payload. These are the resources that I'm about to change. And then we can go and proactively blacklist the CIDR ranges in either the security group or NACL, so that we can basically make sure that this actor isn't able to interface with our environment. Now, the power to this is that because it's being done in this pub-sub model, it allows you to basically ensure that for the entirety of your enterprise that you can make one change to one file, and every account in your organization now will start to block this traffic based on this topic notification. So another area that I see a lot in the government space in particular is people try to make things work like they worked in an old data center, in the legacy environment pre-cloud. And that's one of the areas where it's often not a really good experience for customers, because you're trying to basically shoehorn a technology that doesn't lend itself as well as what you could do on AWS. So let me give you a practical example of that. What I see a lot is customers do this. So for folks that are not familiar, this is an Nmap scan, and this is the worst type of Nmap scan. This is a -A. And what you really need to know, even if you don't know what Nmap is that basically this takes about 3 minutes to complete, and we're scanning one host. What I would argue in an AWS environment is what you're trying to find out is what is our exposure for a particular resource. And the right way to do it from a cloud perspective is do a describe call on the security group. Note that basically at the end, this took about 2 seconds to run, and instead of targeting one host, I'm getting back basically everything that's associated with that security group. So it could be tens or hundreds of different EC2 resources on our environment. Now, there's someone in the audience right now that's saying, yes, but that Nmap scan will tell me if it's actually listening on the instance. And I would argue to you that's irrelevant. And the reason it's irrelevant is the security group allows it. And the reason that's important is, how do you know that an actor is not using a time-delayed function to leverage an opening in that firewall based on an interval or something like a port knock? The answer is that if the security group allows the traffic, and that's not what's allowed via your policy, then it's a finding and you need to remediate it. And that's why it's a much more efficient way to do this type of reconnaissance rather than going and doing that longer Nmap scan. So another design I see a lot is hub and spoke models. So the difficulty with the hub and spoke model is that while it's appealing for smaller organizations and works well at the onset, at larger scale, when you're dealing with hundreds or thousands of accounts, you'll start to see this model break down. So from a data flow perspective, this is what I used to see a lot. We have a customer, a government customer, that is relying on a service like a VPN or Direct Connect. They've got a set of applications that are hosted on AWS, and they've defined their route table to basically take that traffic and flow it back through their data center and then ultimately go back out to the public internet. And the reason that they want to do this is this particular VPC, as you might notice, has no internet gateway. And so what they want to do is basically perform traffic inspection on the host and be able to look at everything that's going over the wire. But obviously that creates a huge latency concern. The other issue is that they're forgetting a key capability inside of AWS, which is that there are VPC endpoints that would allow them to accomplish that same goal of limiting the traffic so that it stays in a private network enclave rather than going out over the public internet. So in this case, let's say that for that S3 service that we wanted to communicate with, we can define that VPC endpoint so that this is still a closed VPC, but we allow communication to that S3 endpoint now. The other reason that this is really important is that it allows us to identify multiple VPC endpoints for an account or for a VPC resource. So in this example, you can see that I've got a number of resources that are going to be pointing to a backups directory, but I have a number of other folks that are going to point to a compliance directory. And we can limit access to the VPC endpoint in the same granular structured language of the bucket policy as you could for the bucket itself. And in fact, it's actually sort of a belts and suspenders approach, because inside the policy for the VPC endpoint, I can say that only a specific subset of EC2 instances can talk to this VPC endpoint and not others. And I can also say that communicating with this VPC endpoint is only allowed to communicate with a specific S3 bucket. So if I want to make sure that basically an adversary can't go and use just any S3 bucket, I can set the policy on the VPC endpoint so that basically I can only communicate with a specific S3 bucket. Another way that we can extend this is through Private Link. What Private Link will allow you to do is basically create customized endpoints for your application and host it in the same model. So the idea is that if you create a customized application, you'll use this endpoint, and you can, again, put it through separate VPCs and allow your resources to communicate with it, even if it's a closed environment. So the other thing that we want to make sure is, how do we keep people from doing things that we don't want them to do? One way that we can address that is through the use of config and config rules. And for those that are not familiar, config allows you to basically set policy inside of your environment and define pre-built rules that look for compliance based on a specific event or a specific context that you're looking for. So in plain English, let's say I want to make sure that SSH is restricted in our environment. So we have a pre-built rule that will do this for you, but just as an example, I'll go and I'll select this rule looking for SSH. I'll associate it with resources. It could be things like a security group. It could be a specific tag. It could be specific EC2 instances. And then I'll say whether or not I want this to be a continuous or a periodic change. So continuous means that anytime someone makes a change to that security group, it will run again. Periodic will be based on a schedule interval. So it could be that based on our compliance framework, every 24 hours, I need to make sure that all hosts have a particular configuration. So what you'll get back basically is a compliance report that shows which hosts have been identified as compliant and non-compliant. But the reason that this is important is that, again, because that config rule comes through as a JSON event, I can use that in correlation with a CloudWatch event trigger and kick off that same rule process that we looked at earlier, where if we find a host that has been identified as non-compliant, we can use that Lambda responder to go and auto-remediate that resource. So in the case of an SSH security group change, we can go and identify that security group and basically go and revoke that change to the environment. We can also do things based, again, on your company's culture and posture, like locking the user's account that made the change. So it very much depends on what your risk tolerance is, but if your organization has laid out a hard policy and wants to make sure that it's enforced, the locking of a user's account is a pretty strong deterrent. It's also important to remember that within the Cloud Trail log, the way that we're able to address that is because the Cloud Trail log captures all the metadata about who made an individual call. It's not that just that we can get the attribution to say that this user performed this operation. I can use it also in correlation with things like what role did they assume to do it, and from what IP address did they come through. So that might tell us things like, if I detect that they're using an unusual role or they're coming from a CIDR block that's maybe in a different part of the world, that maybe someone has compromised that credential. So let's talk about access control. How do we make sure that data going in and out of our environment is secure, and how do we make sure that only authorized individuals can get access to the resources that they need to? So there's a really powerful tool inside the IAM console today, which is called the Access Advisor. So the Access Advisor will allow you to look at a user, a group, or a role and identify what that user has been assigned and what they're actually allowed to do. But the important part is not only will it tell you what they're assigned, it will tell you when the last time they actually used that operation. So it's really powerful to be able to quickly look at whether or not you're giving too permissive of permission to a particular principal inside of AWS. But the difficulty is that it's GUI access only today. So how can we deal with that more programmatically? So this is an example of an Athena query that would let us query the Cloud Trail bucket and look for the same information, what a user has been granted and what that user is actually using. And then we can basically merge the two and identify that if we gave this user ** access, but all I see is that they're using EC2 to run and stop instances, then that might be a good example of that this group or this user has too much permission, and I want to go and revoke that access. So if Athena and doing that framework doesn't sound like fun to you, or that you don't have the time to do that kind of tooling, there are 2 open source products that Netflix put out that help with this process. Aardvark and RepoKid. So Aardvark basically does scraping of the environment via Phantom.js. RepoKid will basically take that data, correlate it with IAM describe calls, and allow you to, as the name suggests, repo the permissions that are basically too broad, too permissive. So an example of how we can do this as a process is there was a really good reInvent talk that we did in 2017 on security event response from idea to code execution. And one of the examples that they gave was, what will you do when an adversary does something that would be a security binary? And in this case, the security binary is stopping Cloud Trail logs. So going back to that Jurassic Park analogy, you've got someone trying to basically mute a log store that records all the operations inside of your environment. There is almost no business justification for doing that. You don't want to cut a ticket. You don't want to have a red light on a dashboard. This is an example of, I want it to be fixed immediately. So in this case, what we can do, again, is use that same CloudWatch metric capability, look at the calls as they're coming through, and basically when we detect that the Cloud Trail stop logging call has been made, we can use that same Lambda responder to go restart the Cloud Trail logging and put it back into operation. So I've given this example a couple times, but I want to show it to you in principle so that you feel like you can trust that this is a real working framework. So let me break out for 1 sec. So what we have here is an IAM console, and what I'm going to do is we're going to go into a user, and what we're going to do is we're going to say that we have a policy inside of our organization that no user is allowed to assign inline policies to a principal. And the idea is that we want them to use managed policies because our security team knows what's in those managed policies, and we can audit against it because it's a known baseline. In this case, what the adversary is going to try to do is be clever and inject a higher level of permission than what they're actually allowed to do. So let's add our inline policy. And in this case, our adversary is going to use EC2. And they're going to go and try to perform a list operation. And because all adversaries are this helpful, they're always so helpful. So we can go in, and we can see bad guy policy is here. And usually within about 5 seconds, it's not. So the reason that it's not there, and I want to kind of demonstrate this specifically, is because I've told you how easy it is to do this. I've told you that the code is not a very big burden. Let me show you the code. That's it. It's 9 lines. So all I'm doing is I'm looking for that CloudWatch event that's being passed to the Lambda responder. The CloudWatch event has the metadata in it that tells me what the resource was. And all Lambda is doing is basically saying, if I see a match in the CloudWatch event that I'm being provided, which is an inline policy has been associated with the principal, it goes and deletes the policy from the principal. Because remember, the CloudWatch event will tell it what it was, which policy it was, and which user performed that operation. So in parallel, this could also be made to do things like, again, revoke access to my account so that the user that performed the operation would be effectively restricted. Now, I'm not doing that because I still want to do other stuff. So the reason that this is important is that we can have workloads that are running anywhere. AWS has regions spread throughout the globe, and we have resources that allow customers to execute those anywhere. But what we're seeing, especially from some of our government customers, is that they have contractual or legal requirements to make sure that their application and their users are based in the CONUS region, or that they're based in a specific region. So how do I make sure that a principal can only perform operations in a given region? So in this case, let's say that the region is US East 1, or the Virginia region. The answer is that there's a new capability within IAM that some may not be familiar with, is the ability to constrain a role to a region. So in this case, you can see I'm adding the conditional statement here, which is that the request region has to be US East 1. So what this will effectively allow you to do is make sure that an IAM principal can only make the call to a US East 1 based region. So what about making sure that the core operating system is secure? How do we make sure that we harden our core OS? One way that we can address that is through a service like Inspector. So we can use Inspector to basically build in part of a DevSecOps pipeline to look at the code prior to actually publishing it to a running instance, or we can look at it after the event. It will integrate with most CI/CD frameworks. So if you're already using a tool like Jenkins, for instance, there's already tight integration with that tool, so you can use an inspector-based scan when you're doing your build process. An example of how easy it is to do this, in this case, we're defining a specific template that we want to use. In this case, it's the CVE inspection. What we'll do is basically associate it with a set of resources based on an individual instance, or perhaps an EC2 tag. And what we get back is a findings report that will indicate not only whether the resource was found to be deficient in something, but we will often be very descriptive in what you need to do to remediate that finding. So it's not just we've identified something wrong, it's your problem. Inspector will tell you how to remediate that particular finding. Another cool capability for Inspector as it pertains to that workflow is that there are rules packages that, again, speak to specific frameworks. So there's a CIS benchmark that's in the Inspector, so we can make sure that the core operating system is hardened to a CIS standard. Also, a really important one is the security best practices template, which allows you to make sure that the EC2 instance has been hardened to AWS security best practices, which means things like if you're using a Linux-based host, you haven't gone and enabled the root user, or you've disabled the SSH public-private key pair use. The other part that's important for the longer-term Inspector runs is that it will look for anomalous behavior of the operating system itself. So what that means is that if you allow the scan to persist longer, it will look for things like the operating system exhibiting unusual characteristics, like every 50 minutes, for some reason, SSH opens for 30 seconds and then closes down. It can detect that sort of anomalous use of a service or anomalous use of a port inside of your environment. And again, that's a good example of an adversary trying to hide a payload based on a timing event or based on a particular trigger event. So let's try to avoid failure where it's obvious. A good example is storing secrets in code. This is something I've seen a number of customers do over the years. They'll bake in credentials into the code that they're actually using in their production environment. So what we would urge customers to do now is leverage a new tool like Secret Store, which allows you to basically set this key material in the application, so that rather than persisting that key material to the EC2 instance, I can store it in the secrets manager and basically allow rotation of that secret on a frequency that you've determined. So the nice part of that, again, is that for services like RDS, I no longer have to persist an actual database credential to the application itself. And again, as I mentioned, another powerful function of that is that, again, if you're bound to something like PCI, where you have to rotate that credential and prove rotation, it's automatically integrated into the service so that you can do that customized rotation. So speaking of keys, another area that I see a lot of customers make a mistake on is giving keys to things that don't deserve keys. So we want to try to make sure that keys are presented only to people, not to things. So the analogy is that you want to make sure that if you have a user, it's okay to give user hard-baked API keys, but if you have an application, never give the application API keys. The application should always be using a role or an STS token to get a temporary credential. Never a long-lived credential, because again, everything that that key is authorized to do, if an adversary is able to get that key from that application, they can do everything that that application is capable of doing as well. So let's talk about when you not only have to track one account, what happens when you have to track a lot of stuff, a lot of different accounts inside of your organization. So one technique that we can use is obviously AWS Organizations. An example of how orgs works, if you're not familiar with it, is that orgs allows you to set service control policies on an organization and its sub-resources. So in this case, you can see at the root account level, I've defined a policy, and we've also assigned a policy at the compliance account OU. And then within the compliance OU, I've broken out two separate OUs based on a particular framework like HIPAA or PCI. And when we look at how this is basically ingested by the downstream accounts, you can see that all the accounts will get the upper policy because it's being pushed down from the root organization. They will all get the secondary policy because it's being pushed down from the compliance account. But notice that the PCI account will only get the orange indicator here because it's in that OU only. And we can apply that same logical breakdown not only to other OUs, but to also individual accounts. So we can associate a policy with just an individual account as well. So for folks that are not familiar with the service control policies, effectively what it allows you to do is blacklist and whitelist different functions inside of your environment. And the reason that's important for customers is that when you give this type of access to administrators in those accounts, we want to make sure that an administrator cannot override the permission that's being pushed down as a policy. So a local administrator, a privileged user in that account can't override this service control policy. An important call out though is that the way that the policy is interpreted is that it is a union of the IAM policy associated well. So you have to take into consideration the IAM policy as well as the service control policy to break that down. The way to make that process a little bit easier, to be honest, is there's a IAM policy simulator that can help you with performing that. So a couple examples. So this is an example of a policy that will do a simple blacklisting. So we're saying that effectively we're going to allow everything except Redshift. For whatever reason, this organization has identified that they don't want users to use Redshift, so we're just going to blacklist the use of Redshift. Other customers take a different stance, which is that they want to do whitelisting. So in this case, we're defining a specific set of API calls, not just to the service, but to the individual call within the service. So in this case, just the describe calls. So how do we use this? So if we look at this from a security account perspective, what we would do is basically have that security account inside the organization. And we can use things like a read-only access role to basically start doing things like describe calls to the member accounts inside of the organization. We can use that SNS topic flow that I talked about earlier, where if we want to broadcast changes to our environment, we can have the individual accounts listen to the SNS topic. We can also do things like via stack sets in CloudFormation in the organization, configure all the member accounts to automatically configure themselves to do things like put their Cloud Trail logs in the central security accounts S3 bucket for log retention. And then we can also do things like create custom CloudWatch metrics as well. So the way, again, that sort of visually that would break down is if we had that organization, the security account would sort of hang off on that first branch and use the cross-account role capability to assume access into those different accounts. Now, an area that I want to make sure that is very clear, this is a very sensitive account. This account can obviously log into all the different accounts inside of your environment. So you want to make sure that access to this account is on a need to access basis, and that you're doing things like following best practices, using multi-factor authentication, looking for anomalous behavior within that IAM principle. But how would I know what's anomalous behavior? Well, the answer is guard duty. So if we're using guard duty in that central security account, one of the things that guard duty can help you detect is anomalous behavior of the individual user. So let me show you that as sort of an example. So going back to our service list, I'm going to go into guard duty. And as an example of an anomalous behavior for a user, What we're seeing here on the right-hand side, basically, for folks that are in the back of the room, is that we've identified that a particular principal is making API calls from a location that they are not geographically usually making them from. So in this case, this particular principal usually makes calls from Virginia, but for some reason right now, the principal is making calls in Fort Worth, Texas. So the finding here may be that we simply have a developer that's visiting family or that is working remotely, and we can just let this go. But an important call out for how guard duty works is the actual finding report itself is this JSON structured document. And the reason that that's important is, again, using that same Lambda workflow, what we can zero in on is this. We can make a threat decision based on the country that we're seeing in that guard duty finding. So a good example is that perhaps some organizations may make the choice that if all of my developers are based in the continental United States and I get this type of alert, we'll just mute the alert because we don't consider that to be a normal or unusual behavior. But if I see the developer present in a country that we don't do business in or that I wouldn't expect that developer to be popping up in, then we can use that basically to fire an event that will basically lock that user's account and rotate and remove the API key material. So an important way to make sure that that effectively is pushed out to all of your organization's accounts is that much like organizations, guard duty supports parent-child relationship or master account configuration, where we would use guard duty to basically push itself into the security account, and then we can identify member accounts inside the organization that will listen to guard duty findings, but also broadcast their individual findings. So it allows the security account to basically see all the various guard duty alerts that are taking place across the enterprise. And that's a really good way to do threat intel of your organization, because now that I'm aggregating all this in the security account, I can process it and look for signs that an actor is probing all of our infrastructure. So I can see that the Department of Treasury just got this alert, and then suddenly 3 seconds later we see that another agency just gets the same alert. We can use that in correlation to say that this actor is scanning a specific subset of the IP ranges and use that pub-sub model to push out a block to all agencies that are subscribers to block that traffic moving forward. Another area that's important is enforcing consistency inside of your environment. We want to make sure that everybody uses the same tools, the same building process. So the way that we can do that is through templatization of our build. So in plain English, we want to move away from the old Excel-style checklist of building out our resources and instead focus on templatizing all of it in a CloudFormation template. And the reason that that's important is that it allows us to basically take a template and deploy it again, and deploy it again, and keep deploying that resource in a repeatable way so that we know there's consistency inside the environment. But how do we deal with specific applications then? One of the cool capabilities within organizations and CloudFormation is the ability to do what's called a stack set. And what stack sets will allow you to do is basically push CloudFormation templates out to member accounts and basically push artifacts to those accounts. So if I wanted to make sure that every organization member in our environment had a particular security group configured by baseline, I could push that out as a stack set element, and then when we want to make a change to that security group, I make it to one file, and it will push to all the member accounts inside of our environment. Another way that we can address that is with Service Catalog. So we can provide that same template in a marketplace type offering internally to make sure that our consumers can get that same repeatable infrastructure, but in a way that's perhaps more friendly to consume. One of the interesting use cases for the use of Service Catalog, though, is that if you have an R&D arm as part of your organization and you do things like publish in a peer-reviewed journal, Service Catalog allows you to deploy applications in versions. And the reason that that's really important for those that are in that space, if you are going to publish a peer-reviewed document and 3 years from now someone is going to challenge your finding, usually part of that challenge is the difficulty with reproducibility. With Service Catalog, I can go right back to the particular version that we did our analysis on and provide that third party with basically the exact same environment that we did our analysis with the exact same tooling and the exact same data set configuration. So in summary, we want to make sure that we're leveraging automation as much as possible. Humans, we make mistakes, we don't do things correct all the time. Code tends to never sleep, tends to never get bored, tends to never not do what you tell it to do. So leverage automation as much as possible. If you're going to use AWS for a larger organization, consider the use of the organization service. It will allow you to push policy to all the resources that you have and allow you to automate the distribution of governance and policy controls to those resources in a structured and controlled way. And as of 2 days ago, there was a newer offering that we just released in the beta, which is called Landing Zone. There's a blog post forthcoming, but effectively what Landing Zone will allow you to do is sort of marry the two to create a account vending system, if you will, to basically vend accounts rather than have accounts basically be provisioned on demand. So that's all I've got. Happy to take questions or in the back or hang out, but otherwise, thanks very much for coming.